All right, y'all. This video is going to be a video about everyone's favorite topic, significant figures. If you're not sure what those are, maybe you remember them from chemistry, and if you're a little more familiar with them, they're called Sig Figs, or for short. If you've not taken chemistry yet, or you just don't remember them, significant figures are a way to determine which numbers are important or significant in a measurement. So some of you might be thinking, well, aren't all numbers in a measurement significant? They're all telling us something, which is true. But think about when you're measuring or when someone's measuring a really, really, really small or really, really large object. Those numbers tend to have a lot of zeros in them. Well, how do you know if the zero is just a placeholder or if it's telling you something specific, like it's exactly 1.00 meters? It's not 1.1, it's 1.000 exactly. So this set of rules is a way to determine whether or not a zero is significant. Before I proceed, I want to make it clear that some of you may have already learned some Sig Fig rules from somewhere else, and maybe you're really comfortable with those rules and you feel like they work really well for you. Fine, use them. Skip ahead to the next section to review your knowledge on math. But some rules I've heard before have been confusing to me, so these are the version of the rules that I like that makes sense to me. If it works, great. If not, use what you already know. Awesome. So we're going to dive in. Again, with Sig Figs, we're deciding whether or not a zero is significant or not. So anything that's not a zero, aka numbers 1 through 9, are always significant. 1 through 9 are significant. We're deciding between zeros. So we have three different types of zeros we could have. We have zeros that fall in between other numbers. So for instance, if you have the number 301, 0 is in between two other significant numbers. So it itself is significant. It's telling you that it's not 31, it's not something else, it's 1/10 of a way or 1/10 of a space away from each other. Great. Now we have, let's try another example, 2,000,058. All of these zeros are in between digits that are known to be significant, so all of those zeros are also significant. So the next type of zero we could have is something called a leading zero. I'm going to zoom in over here because I get a lot of questions on this one. Leading zeros are zeros that come in front of the first number if you're reading it from left to right, the first significant number. So, for instance, let's say we have a number with no zeros in it, 21. Technically, if you were looking at all of the numbers that could potentially be in a place, like in the 100th place for 21, there would be a zero there. But we don't often write it because it's not significant. So that would be an example of a leading zero. We don't use it very often, so let me use a more practical example. Let's say we have 0.04. This zero definitely is in front of the 4. So it's a leading zero, and leading zeros are never significant. But what about this one? Right in front of that decimal place. I have heard rules in the past where it's like if it's to the left of a decimal sometimes, and if it's to the right of the decimal other times, but that rule switches depending on when you're looking at it or something like that. I don't actually understand that rule very well, so I don't want you to think of it like that. I want you to think of this zero is included with this zero. These are both zeros in front of that 4. You're kind of ignoring the decimal for now, but they're both considered to be leading zeros because they are in front of that 4. So neither of them are significant. 0.004 would only have one significant figure, or SF for short. Great. The last type of zero we have between zeros, leading zeros. Now we're going to talk about zeros at the end of a number. So all these other rules have been like, they're always true or they're always not true. They're just the same always. So 1 through 9, always significant. Between zeros, always significant. Leading, never significant. This is the one rule that is sometimes, and I'll explain that. So zeros at the end of the number are only significant if a decimal is present. So let's look at a couple of examples. Let's say we have the number 100. These are ending zeros. They come at the end of the number. Is there a decimal in the number? There is not. There's no decimal anywhere. So these zeros do not count. There is only one significant figure in this number. But let's say we have something like 22.50. This number is this 0 is at the end of the whole number, and there is a decimal in this number. So this 0 is significant. So in total, we have 4 significant digits in this number. I'm going to talk about one weird example that you might see, especially in a science class. Let's say we have another 100 type number, and there's a decimal at the end like this. I know most of you are not used to seeing numbers written like this, or not used to seeing it like really anywhere, but sometimes in math or sometimes in science classes when you're taking a measurement, I guess you could do it in a math class too, if you're trying to show that these 2 zeros are significant, you could add a decimal at the end, because these are still ending zeros and there is a decimal in the number, so that would make both of these significant. The only reason we would do this is, like, let's say you're taking a measurement of 200 millimeters and it's exactly 200, and you want to be specific on that and make sure that those numbers are considered to be significant, because they're telling you it's not 201, it's not even 200.005, it's exactly 200. You can add a decimal at the end, and that'll make those ending zeros significant. So ending zeros are significant if there is a decimal in anywhere in that number. So I know it was a lot of information to swallow. I am going to write those same rules right here in kind of shorthand. So I'm going to say the numbers 1 through 9 are always significant. And if you want to copy this down somewhere, this is a really easy chart to copy and memorize to keep them in your head. Between zeros are always significant. Oops. Leading are never significant. And then ending zeros are only significant if there is a decimal. And that could be anywhere in the number. But you get the idea. This is a shorthand version of all those rules. And again, if you don't like this set, if it doesn't make sense to you, use something you know how to deal with. Great, so now we're going to talk about math associated with sig figs. Oh, no, we're not. We're going to do an example first. Just kidding, just kidding. So yet another example. How many significant figures are in this number? This is from your notes. So if the answer is down at the bottom, but let's figure out why. So going through the 4 rules that we know, anything that's not a 0 is considered to be significant. So we at least have 5 significant digits in this number. Second rule, between zeros. This is a between 0, so that is definitely significant. So we can say we at least have 6 significant digits. Leading zeros, zeros that are at the beginning of a number, even though there's a decimal, never count. So none of those matter. Ending zeros only matter if there is a decimal in the number. And there is. So this 0 is significant. So I would say 1, 2, 3, 4, 5, 6, 7 sig figs in that number. So now the math. When you eventually will have to do a math with this class and with the measurements that you take in this class, and people struggle with what do I round to keep the right amount of sig figs in my number. So it depends on what you're doing. So addition and subtraction follow different rules from multiplication and division. But if you look at these 2 sets of rules, you're always rounding to the least amount of something. You're always rounding to the smallest amount of something that exists in the numbers that you're using. Kind of confusing. I'll explain a little better in a second. So when you're adding or subtracting, you want to round to the least amount of decimal places in the original numbers, or in the numbers that you're adding together. For instance, let's say I'm adding these 2 together. 34.4 has 1 decimal place. I can count decimal places by counting how many numbers come after the decimal. There's 1 decimal place in that number. Versus, sorry, I'm going to make mine a little skinnier. The second number, there's no decimal. And if there were, it would be right there, and there's nothing after that decimal, so there are no decimal places after 21. So between these 2 numbers, 0 is the smallest amount of decimal places, so you will round your answer to no decimal places. So if you were to type this into your calculator, 34.4 plus 21, you would get 55.4, but to round it, you would round it to the smallest amount of decimal places in those two numbers that you added together. So with multiplying and dividing, you kind of follow the same idea. You want to look at the numbers that you're mathing with, and this time you want to round to the least amount of sig figs that are in those numbers. So here's an example, and that's a division sign if you weren't familiar with it. We're going to count sig figs in each of these numbers. So 11.5 has 3 significant figures, and 5.0, oh no, has a 0. It's a little tricky. There's an ending 0, and there's a decimal, so it's significant. So 2 significant figures total. So when I type this in my calculator, you may get a different answer. But whatever it is, I'm going to round to 2 sig figs, which is what we have written for here. So that can be tricky to memorize. I get that. Here's how I remember it. Out of the sets of math functions, adding and subtracting and multiplying and dividing, addition and subtraction is easier, or at least I can sometimes get away with using my fingers to add or subtract. I can't exactly do that with multiplication, and I know some of you can maybe do that in your head, multiplication in your head. I can't always, so I usually need a calculator for multiplication and division for this one. So for me, how I remember it, with addition and subtraction, I use the easier rule, which is decimal places. It is way easier to count decimal places because you're literally just counting the spaces after the decimal. Versus sig figs, you kind of have the more difficult rule. And while sig figs may not be difficult for all of you, you still have to think about it. You're not just counting. You're like, oh, does it come at the end with a decimal, or is it at the beginning or in between? You have to think about it. So you're going to use sig figs for the more difficult math function. You're going to use the more difficult rule. And that's how I always memorized it in my head. If that helps, use it. If not, don't worry about it. So I'm going to go through the 2 examples in your notes, and then we'll be done. We're multiplying 7.5 times 30, and I want to round the answer to sig figs, so you would probably get 225 in your calculator, but how do you know if that's what you're supposed to round to? Well, when I'm multiplying, I round to the least number of sig figs in both of my numbers, or all of my numbers if you have more than 2. So 7.5 has 2 sig figs. 30 has an ending 0, but there's no 0 in that decimal, or there's no decimal place with that 0. So only 1 sig fig. Since that's the smallest amount, that's what I'm going to round my answer to, which is why C is the appropriate answer here. For this next example, we are subtracting, which means I need to pay attention to decimal places instead. There are 2 decimal places here. There's only 1 decimal place here. Again, only spaces after the decimal. So I'm going to round to 1 decimal place, which means my answer would be A. Please do not hesitate to ask your teacher, your friend, or anybody else if you need more clarification on sig fig